1 when we haven't figured out.
Okay, so yeah, if you haven't defined what k is, it's 1. But actually, in this setting, k is a little different than that. So k, yeah, just k, if we haven't defined it, equals 1. But now in the setting of this function, it actually has a different role. So what is the role of k? It's not, so yeah, if I hit graph, nothing's going to happen. So, yeah, so nothing, there's nothing to graph, okay? So what is the role of k in this command line? What does it mean? Oh, by the way, just don't type anything. Don't go ahead of me. We want to look at these and practice thinking. Okay, what's going to happen? So don't do it before I do it. So just close your laptops. Okay, just close your laptops. All right. So we want to be able to anticipate with the mathematics what's going to happen. So what is the role of k in that line? Anybody? Yeah.
The input.
Okay. Yeah. So it's what's called a local variable, and it's in that line. It means the input of s, right? It means the input of s, and then so whenever we invoke s, whatever's in those parentheses, it's going to do what? Yeah. Yeah. What's the instructions that it's going to do on it?
Well, it's going to take whatever that number is and add radical of that number.
Right. So whenever we invoke the function s, it's gonna look for what's in the parentheses, and it's gonna take that, and it's gonna do what? It's gonna take that value and add the square root of it, and that will be the output. That given that. So we just defined this rule. We haven't graphed anything. Okay. So what if I put in? I'm gonna put in s of 9. Okay. I'm gonna put in s of 9. What's gonna happen now? Gonna give me a graph? Nothing.
It's going to give you the output.
What's that?
It's going to give you the output.
He says it's going to give the output. What do you think? Let's do it. Where did the number 12 come from? What does that mean?
It's 9 plus the square root.
Yeah, so like we said, it took what was in the parentheses, and it did the rule according to how we define the function. And so what is, when you see that whole expression s of 9, what does it mean? What does that whole expression s of 9 mean? So it equals 12, but what does it mean?
It's the function s of k with an input of 9.
Okay, is it the function? Is it that symbol s of 9? Is that the function?
It is the value of s of k.
That's not output.
It's the output. Remember, that's what we learned. So that whole expression there is an output. You got to be able to see. You got to see that when you see that function notation, you have to train your mind to see output. That's output. Which output is it?
12.
So forget the 12. What output is it?
S when k is 9.
Okay, so
S of what? No, right.
So is it
what output is s of 9? Yeah.
also, would it be 9 comma s of 9, like as like a coordinate, or?
So okay, so that's you're describing the ordered pair. I'm asking what output is s of 9? What output is s of 9? Quick.
It's the output when the input into the function s of k is 9.
Okay, it's the output when the input is 9. It's the output when the input is 9. That's what it is. Okay, so then again, so what about if I put, let's see here. What if I put, I'm going to change this, I'm going to put s of a. So I'm going to type in a there. What's going to happen? Graph, number, nothing. Somebody new. So where is Ariana? Same as above. So when I put a in there, a plus radical a is going to pop up.
Or it would be, I guess it would be
I'm fine. Okay. Somebody new. 1. So you say the value 1's going to come up. Okay. What do you think? So we got undefined. We got 1. We got that expression a plus radical a. What's going to happen if I put a in? Let's see. Where is Connor? Sutton.
I want to say 2.
Tell me why.
Is it a itself is 1?
Okay.
We added more
Okay.
So 1 plus 1 would be 2.
So you're saying by not defining A, it has a default value of 1. So so what would that expression be, S of A? It'd be the, what does that mean?
Output.
The output when?
When you use A. When the input is A.
Which is?
1.
1. See? So if we don't define what A is, it has a default value of 1. And so now, the function S is going to see, oh, there's a 1, so this is S of 1. This is the output when the input is 1, which is 2. Okay, now I'm going to do Y equals S of 4. Okay, so I'm going to put a 4 there. Now what's going to happen? Y equals S of 4. Value, graph, nothing, undefined. Tell me your name.
Peter,
Peter.
look at a graph.
What graph?
The graph of a line. A straight line going across.
Okay.
At
All
the
lines are
value-
straight. What kind of line do you mean?
A line at the value of S4.
Which is what?
The input, or the output of S when K is 4.
The output of S, okay, when the input is 4. And so, what is that?
6.
6. So you're saying it's going to be a horizontal line at 6. Anyone else thinks you like that?
Yeah.
What do you think? Is that right? So these are great questions. Why? Because it really forces you to understand what functions are about. This notation, function notation. What does it mean? Because graphing calculator treats functions exactly the way we learned. Okay, and so we need to understand when we put stuff in. And so what I really wanted was the graph all along. I just wanted the graph of the function s. The graph of function s. How am I going to get that? What's that? Okay, so I'm going to put y equals s of k. I'm going to get the graph. Somebody here. Where it is? Christian.
That's me.
You've done your time. But I appreciate it. Jacob. Where's Jacob? Jacob, type in? Yeah. Was it Sterling? Sorry. Tell me what's going to happen. I'm going to put s of k. Y equals s of k.
Nothing will happen.
Nothing.
You should put s of x if you want to graph.
If I want the graph, I should put s of x. All right, we'll come back to that. What's going to happen if I put s of k? Melanie. Cheating. What's going to happen? Okay, Christian.
Wouldn't it just come out as 2 again because you haven't defined K yet?
Okay. So in this line, if I use k in this line, what will it be? No k. Yeah. Okay. So that you're saying that's the result. But what is k? Yeah. Now in this line, it's no longer. If I put k in here, it's not a local variable helping us to define that function. Now it's just going to be like a parameter that we haven't defined yet. So we'll have the value of
2.
no k. The k will be 2, and so then s of k will be 2, and then we're going to graph y equals 2. See?
That happens because you didn't define k, right?
Right, it's assuming that k is 1 in this line. In this line, it's different. K is a local variable helping us to define the function. We could have used a, we could have used b, z. It doesn't, well, not z, but you could use a, b, d, m. Anything that's not taken by graphing calculator, we could have used, and would serve the same purpose of defining this function of take the input and add the square root of the input. But now in this line, you put k in there, and it's saying, oh, that's the input value, and as far as I know, k is 1. Yeah.
So what would happen if you put y equals s of k, and then the next time you would put s of k equals k plus random k? Would that be the same answer?
Yeah, the order, in graphing calculator, the order of the command lines doesn't matter at all.
Okay.
Yeah. The order of your command lines doesn't matter at all. Okay, is this making sense? All right, so how do we get the actual graph of that function s? S of x. Okay. Why? Because x and y are reserved in graphing calculator. X is going to be, it's like a spray. It's like, x is like every value thrown into the function, and then y is going to be every corresponding output for all those x's that we threw in. Question?
Why is x represent? I don't understand what x is doing.
So x is a variable that takes on every x-axis quantity. So whatever our quantity that we want on the x-axis, x takes on every single value. It takes on -4, it takes on -2, 1.5, 3.1, 5.6. Every single real number. And so when you do this, it's going to take that whole set and throw all those values into the function and get each corresponding output out and plot those points.
See.
Plot those points.
That makes sense.
So x and y are changing quantities.
Right.
X takes on every input value, and y takes on all the corresponding output values. And so
x plus square root of x, right?
yeah. So tell me about this point right here. Oh. So relative to our function s, tell me about that point. What's the meaning of that? Did I just add a point to the graph?
No.
No, it was already there. I just highlighted it, right? So what can you tell me about whatever that ordered pair is? I don't know. What is it? 3 point something. Let's make it hard so we don't know. So 3.203. Great. And there's some y coordinate. How can we represent that y coordinate? S of 3.203. So now this point right here, if it's 3.203 and S of 3.203, what's the difference between that point and this point? Awesome. So tell me, what's the distinction between that point in the xy plane and that point in the xy plane?
Well, the new point you put on there for the x value that doesn't have, that's not the correct y value that it corresponds to.
Okay. So it's not about being correct or not. That's a point, right? That's a valid point. So just how does that point relate to our function?
It's not on the graph.
Okay.
Not covered by the function.
And so then what does that mean?
It's not a unique answer for the input of what, I don't know if that's 2 or 1.5.
Yeah, so whatever that ordered pair is, yeah, so yeah, whatever that is, 1.8, 1.7. Yeah, Austin, yeah, that was good. You got it. Because 1.7 put into the function, how does it relate to that y value? What's that?
S of 1.7.
That's S of 1.7, I think.
Not exactly.
Oh, I mean, it won't be.
It won't be S of 1.7, right? It won't. So this is not a valid association of quantities according to our function. But this one is, right? This one is. Every point on the graph is a valid association in the S relationship. Okay? Every point not on the graph is not going to satisfy this function. Okay, so really got to understand that. So we can use this. And so these are the kinds of issues where you type something in and you say, oh, I didn't get the graph, right? So it's all about understanding the mathematics, why you do or don't get a graph, okay? Or a different graph versus the graph you wanted. Okay, so you've really got to understand that mathematics to do that. So let's look at, so I think you guys had this, right? So lots of students in the past have defined the function this way. They knew they wanted to graph the input as a number of payments, so they did this. And maybe this is something you guys did too. Some of you did this too. Talk to me about this. So now I want to define my function b as input variables p, r, m, and x. And then here is my rule using p, r, m, and n. So what's your reaction to this?
Do you want us to graph it? Or?
No, I want you to just comment. What's going to happen?
There's no y equals, so you can't make a graph.
Okay, this is not going to graph. But this is the line where we're defining the function, right? It's not going to graph because there's no y equals, right?
Since x isn't one of the variables
Okay.
in there, it won't mean anything.
So we wanted x to be associated with what? N. Is graphing calculator going to know that from the way we put this in?
No.
It's going to have no idea that you meant what goes in the fourth input, we want to put it there. It's going to have no idea. So what's n going to be?
It has to just be n.
It's going to be 1. So in this function, so defining the function this way, you just make capital N 1 forever. Forever. Anytime you invoke the capital B function, capital N will be 1. It has no way to know the association. So when we define this function, how do we want to define it? How do we want to change this?
You actually have to define the values of p, r, m, and n.
No, that's just finding a particular output. Then if you're saying set these as values, well then you're just going to get one particular output. We want the function of all 4 variables. Tell me.
Well, first you put the n back, and then
What do you mean put that back?
replace the x with n.
Okay. And what will that do? Now, so what's going to happen now?
Well, that, I guess, sets your function up.
Okay, so now whenever we invoke the function b, it's going to look at that 4th value that you put in, and what's it going to do?
Define it as n.
Yeah, it's now going to replace all the n's in your rule with that value. So now we've made the right association, okay? And now I want to graph it as a function of n. So what? Then, yeah.
Well, would you have to make a new command line?
Yeah, new command line, right? So this only defines the function, doesn't graph it. So we need a new command line. And what will it be? To graph it. Somebody new. Where is Peter Coop?
You would set a target command line and say y equals.
Y equals?
The b, r, p, and n.
Okay.
And then to get a graph, you have to set x equal n.
Where am I going to put x's in this whole thing?
Where the ends are.
X there and there and there?
Yeah.
What do you think? Agree with that? So he wants to do y equals this expression. And then do you want to write this again? You want to write this out again?
You don't have to.
Yeah, because we defined our b function as this rule. So now we can say y equals this function. And we actually now have chosen values of p, r, and m. Okay? And then your n value is x. And we want to look from 0 to 360 payments.
I did a little bit differently.
Okay?
And I got the same.
So what did you do differently?
I did, my next command line was the function b, parentheses, all the numbers,
Okay?
and then where n was, I put an x, and then I graphed that.
So you did y equals this rule, and you plugged all the numbers in? No?
No y equals, just the function. I
Okay.
graphed the function with x replacing n.
I mean just the rule. So all you did was write this. All you did was write
Yes,
that.
write that with p, r, m defined with those numbers,
Yeah.
and x replaced n.
So you just wrote this right here.
Yes,
Right? You didn't put the y equals.
I did not.
Okay. Yeah, so this is good practice. Just always put the y equals in. So I suppose it will graph it without it. But whenever you do y equals something, that will, we'll never miss, right? So but that worked. Okay. All right. So now I want to graph this thing. Anybody have a question? Does it make sense? about defining the function this way, and then now we want to graph n as our horizontal quantity, so we want an x there, setting these p, r, and n constant. So what's it going to do? It's going to, everywhere there's a p, it's going to put that. Everywhere there's an r, it's going to put that. Everywhere there's an n, it's going to put that. And now it's going to spray all x values between 0 and 360 in for the n's, and find the corresponding y values, and give us a curve of all those points. Yeah?
Is it possible to make a less than or equals to sign on a graphic calculator?
Yes, it is. If you, yeah. So if you go to help, if you ever can't find something, go to help, keyboard shortcuts. There's a window of keyboard shortcuts. Okay. Which will be different. So it's going to be different for Mac and PC. So I can't, I'm not going to have time to go through every single one and teach every one. So find what you need, okay? But on a Mac, it's, and it didn't make, you know, whether you use less than or equal in this assignment that didn't affect anything. Okay? So on a Mac it's option less than. So if you go option, comma, you get less than or equal to. Option, comma. Or option, period, gives you the less than or equal to. But in this, for this assignment, it didn't make a difference if whatever you used. Either one. Is there another question? Yeah.
I did the control, either one.
Okay.
But it gives you multiplication symbol.
Yeah, so check, does anyone know how to do less than or equal to on PC? Did everyone figure it out?
Control shift and then
Control shift, comma,
less than.
or control shift, period.
Control shift whatever you're.
Yeah. Okay, so now we're going to graph it, and of course we see nothing. Why not? Turn this off.
You get to zoom out a bit.
Yeah, because, so now you got to think about these quantities, right? This is all about attending to the quantities in your function. What's our x-axis quantity? What do we want to show on the x-axis? 0 to 360. So I want to zoom out or in? Zoom out on x-axis until we can see 360. Okay, perfect. All right, now, what is this calculating? What is our output? What's that? Okay, what is the meaning of the output? Like, what quantity is it? What is it giving us? What's that? The balance of the loan. So it's going to start at 100,000 and go to 0. So that's where so the balance of the loan, and so we want to zoom out on the y-axis. So we're showing that function from 0 to 360. And so does it make sense? As you make more payments, what happens to your balance? Goes down. So just quickly here about mortgages. What happens? How does it go down at first?
Slowly.
More slowly, and at the end? Why? Is it just
Because your principal gets smaller.
yeah, in those first, yeah.
I was saying principal first, and then you have to include the interest rate, so it doesn't make much. It kind of keeps it as high, but then as soon as the other more payments you make, the less the interest will affect the actual amount.
Yeah, you're paying a simple interest rate on whatever the balance is. So at the beginning, you're paying lots more interest and less towards paying off the loan. So as the balance finally starts to come down, then the amount is less, so your interest that you pay is less, and you pay more towards paying back the loan. So that's why it's going down, or your balance goes down more slowly at first and more quickly for the end. Okay, any questions, other questions about the homework? So let's get you started on the packet. So you want to work on this for the rest of class. It's a graphing calculator. It's teaching you more things that we'll need about graphing calculator. And then we can circle around and troubleshoot with you. And this packet is due Wednesday. And you have your constant rate of change reading and reflections due Monday.